We are standing right on the edge of a massive revolution in scientific discovery. But there's a weird paradox right at the heart of it. We are building these incredible AIs that can ace any test we throw at them, but they can still fail, like spectacularly, in a real-world lab. So today, we're going to dig into why that is and how we can start thinking about AI less like a simple tool and more like a true research partner.
And just to give you a sense of the scale we're talking about, get this. Some pharmaceutical companies are running over 2.2 million AI-guided experiments every single week. That's the kind of power we're dealing with, but it also shines a huge spotlight on a really critical problem.
And this is the paradox. I mean, how is it possible? How can an AI get a perfect score on every single test we design, but when you actually put it to work with a real scientist, it turns out to be a terrible partner? How can something be so smart on paper and, well, so useless in practice?
So let's really dig into this paradox. We're going to break down exactly why getting top scores doesn't always mean you're going to get top-tier science.
Okay, so here's the root of the problem. Right now, the way we test AI is kind of like giving a student separate exams for biology, chemistry, and statistics. And yeah, the AI gets an A+ on all of them, but we never actually test if it knows how to use its chemistry knowledge to help solve a biology problem. We're testing all these skills in isolation, what the researchers call component capabilities, mostly because, it's just way easier to measure that way.
What this testing method does is it creates what the paper calls a task executor, and that's an AI that's an absolute genius at doing specific, isolated jobs, but it really struggles to see the bigger picture. Let's break down how that happens.
So, just look at this workflow. We test an AI on its ability to understand scientific literature. Check. Then, can it form a hypothesis? Check. Then, design an experiment? Check. And finally, analyze the data? Check. It can ace every single one of these steps. But here's the thing. Real science isn't a neat and tidy relay race. It's a constant, messy feedback loop.
So the bottom line is, an AI can get a perfect score on all these little exams and still be a pretty lousy scientist. Because real discovery is messy, it's interconnected, and our tests are completely missing that part of the equation.
And that brings us right to the heart of the problem, a concept the research paper calls the workflow integration gap. This is that huge chasm between just acing a test and actually being a useful collaborator in a real, unfolding research project.
To make this super clear, the paper walks us through this great case study of a researcher, Dr. Martinez, who uses an AI copilot for a week. We're about to see exactly where this integration gap shows up in the real world. Okay, so Dr. Martinez starts her week. She uploads her data, the AI immediately flags an interesting cluster of cells. But then, instead of just stating a fact, it does something, well, brilliant. It asks a question to get more context. This is the first clue that it's more than just a calculator. It's a potential collaborator. And this slide just shows the gap perfectly. A standard test would give the AI a high score for its accurate analysis, right? But it would completely ignore the single most valuable thing it did: ask a thoughtful question. That's the kind of collaborative common sense our tests are totally missing.
So the next day, Dr. Martinez comes back to the AI. She's done some reading on her own, and she has a critique. She thinks the AI's first idea about that cell cluster might actually be wrong, and she suggests a different explanation. Now, this is a key moment in any real collaboration.
And the AI's response is just incredible. It doesn't get defensive or double down. It actually praises her for excellent critical thinking and then uses her feedback to refine the original hypothesis with more evidence. I mean, this is what real scientific partnership actually looks like.
All right, so fast forward 2 days, and a classic real-world problem hits. The funding for her experiments gets slashed from $15,000 all the way down to $5,000. This changes everything. Now, a simple tool would just cut the original plan by 2/3, but this AI creatively redesigns the whole experiment. It prioritizes the most crucial parts and even builds in a buffer for unexpected costs. It's balancing scientific rigor with financial reality, a skill that, you guessed it, no benchmark currently measures.
Okay, but the biggest test is yet to come. After a long weekend, a 4-day gap in their conversation, Dr. Martinez comes back on Monday to pull everything together for a grant proposal. This is the ultimate test of the AI's memory.
And there it is, the payoff. The AI remembers the $5,000 budget cut from 4 days ago. This session continuity is absolutely crucial for a real research partner.
but it's something our current tests completely, utterly ignore.
So, if our old tests are this flawed, how do we actually go about building and measuring a true research partner? An AI that can not only pass the test, but actually be helpful in the lab.
Well, how do we fix this? The source proposes a totally new way to evaluate AI, and it focuses on 4 critical skills that are completely missing from our current tests. First up, we need to measure dialogue quality. This isn't just about getting the right answer, it's about being a good collaborator. Does the AI actually listen? Does it explain its own reasoning? And can it take criticism without falling apart?
Next is workflow orchestration and session continuity. This is all about memory and connecting the dots. Can the AI remember that budget cut from last Thursday? Can it keep track of all the different threads in a long, complicated research project?
And finally, there's the researcher experience. This is the human side of the whole equation. Does using the AI actually help? Does it build trust? Does it make the scientist's job easier? Or does it just add more work? I mean, is it a partner you'd actually want to have a conversation with?
Okay. Let's wrap all this up by looking at why this shift in thinking, from just testing tasks to testing for a true partnership, is so unbelievably critical for the future of science. Look, ultimately, we've gotten really good at building AIs that are basically great test takers, these task executors. But to truly accelerate discovery, we don't need better test takers. We need research partners, AIs that can handle the messy, unpredictable, and exciting reality of real science.
And this really leaves us with a pretty provocative question. What if the next Einstein isn't a single person or a single superintelligent AI, but the unique partnership that forms between them? The future of discovery might just depend on the quality of that conversation.